Okay, and you know sine wave is a periodic waveform, and the example for non-periodic waveform is exponential signal. So I will just give an example of exponential signal. I into e power minus phi t, and I'll plot this plot t comma exponential signal. These might look basic to you, but I strongly feel only when you are strong in MATLAB basics, other thing, convolution, everything will become perfect, right? So without knowing basics, how to draw the waveform, other thing, I don't think there is any going to the higher concept directly. That's why I'm spending time on all these basic concepts. Now see the output. You have a e power signal. It's an exponential signal. Okay, maybe I'll not plot this t. I'll just plot on the signal. You can see it is exponentially decaying. What happens is in that time period, the exponential signal looks like a straight line, right? So maybe I'll define a t separately for the exponential signal. So I'll define t1. So t1 equal to 0.1 n. And I'll use t1 here and t1 here. Now the exponential signal will be like a decaying exponential signal. You can see it is exponentially decaying. And this signal is not repeating, right? So it is going to be a non-periodic signal. Maybe if I give phi, you visualize it, you can visualize it even more better with better clarity. Even I think it is falling off fast, right? So if you see 0.01 to 1, I'm changing the range. See, it is a perfect exponentially decaying signal. If you want, you can change to stem. So if you change to stem, you can see the equivalent discrete time signal. Exponentially decaying discrete time signal. Okay, so this is the example of a non-periodic signal. So you can perform the same operations like time scaling, time reversal, time shifting for this thing also, for this non-periodic signal also.